Pluto is a remote and bewildering, more unpretentious planet that was once a part of our sun-stimulated system's planetary assembly. However, later, remarkable announcements from prominent astrophysicists Neil deGrasse Tyson and Makaku have brought Pluto back into the spotlight with an astonishing disclosure. They claimed that the cold world is on a potential impact course with Neptune. However, how could this actually happen? Moreover, what might be the repercussions of such a giant event? Are we witnessing an intriguing, colossal cosmic oddity? Or is there something more to this oncoming celestial clash? Join us as we consider the possible outcomes of a Pluto-Neptune impact. Pluto, a former planet that was reclassified as a dwarf planet, partially due to its eccentric orbit, remains a subject of interest and evaluation within the cosmic community. According to recent data by leading specialists, Pluto's orbit is dangerously close to Neptune's. Both Neil deGrasse Tyson and Makaku have sounded the alarm about a possible dangerous collision between these two bodies, which could represent a serious threat to Earth. How is such an event even possible? Pluto's orbit around the Sun is unlike any other in our close planetary system. It takes a staggering 248 years to complete a single revolution. Since its discovery in 1930, it has likely not yet completed one full orbit. But that's not all. Pluto's orbit is marked by a sharply elliptical shape, straying far from the nearly circular orbits of the major planets. What makes Pluto's path even more remarkable is its inclination, tilted at a steep 17 degrees from the ecliptic. This highly slanted orbit adds layers of complexity to its orbital arrangement. One of the most interesting aspects of Pluto's orbit is its intersection point with Neptune's path. For around 20 years in each orbit, Pluto actually comes closer to the Sun than Neptune, challenging our expectations about their relative positions in the planetary system. This raises a common question. Why hasn't Pluto collided with Neptune? The answer lies in gravitational interactions among the planets. The evaluation of Pluto's orbit began soon after its discovery. Initially, astronomers tried to understand its peculiar motion compared to other planets, whose orbits lie relatively close to the ecliptic plane. Pluto's orbit stood out due to its steep inclination and elongated shape. The mystery deepened with confirmation that Pluto's orbit indeed crosses Neptune's. Yet, the stability of Pluto's orbit amid these complexities is a testament to the intricate design of celestial mechanics. The three-body problem, concerning the gravitational interactions among Pluto, Neptune, and the Sun, illustrates the challenges of predicting their future paths. It's like trying to anticipate how three objects will move based on where they start and how they pull on each other. In Pluto's case, these complex interactions involve terms like libration and resonance, along with a phenomenon known as chi-waving. Libration, in the context of Pluto and Neptune, refers to the oscillating motion that ensures Pluto is never in the same region of space as Neptune when it crosses its orbital path. At its closest, Pluto remains at least 90 degrees away from Neptune, a critical spatial separation that prevents collision. Resonance, on the other hand, refers to the periodic alignment of celestial bodies. For Pluto, this means that when it approaches its closest point to Neptune or another giant planet, it is positioned well above or below their orbital planes, providing yet another layer of security. Another crucial component of this scenario is the chi-waving, named after scientists von Zippel, Kappas, and Lev, who studied gravitational motion in space. It describes how three celestial objects like Pluto, Neptune, and the Sun influence each other's movements. In Pluto's case, chi-waving helps explain why its orbit remains so unusual, yet stable, even if it appears out of sync. Despite this apparent disorder, Pluto's orbit has remained stable for billions of years. This suggests that, though its path may seem chaotic, there is an underlying order to it. Predicting massive cosmic events, especially those involving chaotic orbits like Pluto's, is extremely challenging. The inherent volatility of such systems makes long-term forecasting riddled with uncertainties. Mathematical simulations are a powerful tool for modeling celestial motion, but they also reveal our limitations. These simulations depend heavily on precise initial conditions and accurate representations of gravitational interactions. Even small deviations can result in vastly different outcomes, making accurate predictions extremely difficult. Moreover, the turbulent nature of celestial orbits, such as Pluto's, reminds us of the ever-evolving and dynamic nature of the universe. Though we've made tremendous progress in understanding space, Pluto's case highlights how much remains unknown. Understanding the gravitational influence of the giant planets on Pluto's orbit offers valuable insights into the dynamics of the solar system. It illustrates how the position and mass of each planet can profoundly affect the stability and behavior of other celestial bodies. So why are prominent astrophysicists now raising concerns about a potential collision between Pluto and Neptune? Despite the resonant forces that typically prevent such an event, Neil deGrasse Tyson, a leading astrophysicist and advocate for advancing cosmology, provides a compelling perspective on the mysteries of our nearby planetary system, especially the curious case of Pluto. Tyson, known for his role in Pluto's reclassification as a dwarf planet, emphasizes the importance of evolving scientific understanding. He sees Pluto's renaming not as a downgrade, but as a reflection of our growing knowledge of the many bodies orbiting our Sun. Tyson's view of celestial mechanics is rooted in ongoing discovery. He considers the complexities of orbits like Pluto's a symbol of how much more we have yet to uncover. The fascination with these questions, especially the potential interactions among far-flung bodies like Pluto and Neptune, continues to captivate scientists and the public alike. As new models and simulations advance, the possibility, however remote, of celestial events like a Pluto-Neptune interaction becomes a topic not just of scientific intrigue, but also of public curiosity. The idea of a potential collision may sound like science fiction, yet it underscores how dynamic and unpredictable our solar system can be. Makaku, alongside Tyson, emphasizes that even with all our data and technology, we are still in the early stages of truly understanding orbital dynamics at this scale. The vastness of space doesn't guarantee immunity from unexpected gravitational shifts, especially over the course of millions or billions of years. Despite the theoretical improbability of a Pluto-Neptune collision within our lifetime, the conversation itself is valuable. It pushes the boundaries of what we know and encourages us to develop more refined models and instruments for cosmic prediction. In that sense, the scenario serves as a catalyst for scientific growth rather than a call for alarm. Moreover, examining Pluto's orbit in relation to Neptune's offers a rare opportunity to reflect on the protective harmony that seems to exist in the architecture of our solar system. Whether through resonance, libration, or gravitational buffering, it appears that natural mechanisms are in place to maintain order amid apparent chaos. Still, cosmic history reminds us that disruptions have occurred before. Asteroid impacts, planetary migrations, and even rogue celestial bodies have shaped and reshaped our solar system over time. In this context, any discussion about planetary paths and potential collisions, no matter how far-fetched, helps us stay alert to the universe's ever-changing nature. Ultimately, Pluto remains more than a cold, distant dwarf planet. It is a symbol of scientific curiosity, a marker of how much we still have to learn, and a reminder that even the smallest bodies in our cosmic neighborhood can have profound stories to tell. As Tyson often suggests, the universe is under no obligation to make sense to you. But through inquiry, observation, and imagination, we inch ever closer to understanding it. So, will Pluto and Neptune ever collide? Probably not. But asking the question invites us to explore the astonishing balance that governs our cosmic environment, and to stay curious about what lies just beyond what we currently know. Pluto and Neptune highlight the unpredictable and dynamic nature of our nearby planetary system. His work focuses on the fact that the more we uncover about space, the more questions arise, encouraging us to investigate further and improve our comprehension of the universe. Michio Kaku, another respected physicist and futurist, offers a different option. However, a supplementary viewpoint on the mysteries of space, with an emphasis on the idea that our universe is shaped by turbulent forces. Kaku is known for his ability to connect complex scientific ideas with visionary concepts. His concepts make him an important voice in discussions about the mechanics of the heavens and the broader implications for humanity. Perspectives on Pluto and its orbit underscore the need for continuous observation and advanced modeling to predict and understand potential cosmic events. He sees the connections between celestial bodies as a critical area of study, not just for academic interest, but also for practical applications. The potential impact between Pluto and Neptune, for example, isn't just a hypothetical situation, but a manifestation of the dynamic and frequently violent nature of the futurist space. Kaku's viewpoint urges us to consider the broader repercussions of such occurrences, from their impact on our understanding of the solar system to the possible need for future space interventions. His perspective highlights the importance of being prepared for the unexpected in space. Kaku suggests that the more we grasp the forces at play, the better prepared we will be to navigate and possibly lessen the negative effects of significant events. Both Tyson and Kaku's viewpoints converge on the idea that space is an area of boundless discovery and that our present comprehension, while significant, is still limited. Their emphasis on the need for ongoing research and advanced modeling mirrors the expanding field of space science. They highlight the importance of not only understanding celestial mechanics as they are now, but also thinking about how they might alter themselves in the future. The potential impact scenario between Pluto and Neptune serves as a case study for the broader challenges and opportunities in space exploration. It places an emphasis on the need for robust scientific inquiry, cutting-edge technology, and a willingness to adapt our understanding as new information emerges. The enigmas of space, illustrated by the orbit of Pluto, are a reviving call for the scientific community and humanity at large to keep pushing the limits of our knowledge. There is widespread scientific agreement that, long into the future, the orbits of Pluto and Neptune will remain stable due to their average movement, resonance, and various gravitational forces acting on them. Therefore, a direct collision between Pluto and Neptune is incredibly unlikely. However, the intricacies and potential disruptions in orbital dynamics still suggest that space experts should continue to monitor and study these celestial bodies to better comprehend their behavior over time and any potential risks they might present. While the possibility of a Pluto-Neptune impact is mostly theoretical and considered unlikely in light of the current understanding, it emphasizes the importance of continuous review and observation in space science. Advances in technology, including more sophisticated telescopes and computational models, will assist astronomers in improving predictions and simulations, ensuring that we keep up with the dynamic and ever-changing nature of our nearby universe. Tyson's perspective on the planets, the renaming of Pluto, and Kaku's emphasis on the unpredictable nature of cosmic mechanics both emphasize the need for continuous investigation and an adaptable comprehension of our universe. The potential impact scenario, while emphasizing the dynamic and complex interactions within our nearby planetary system, ultimately reminds us of the vast yet still murky spaces in our understanding of space. Through continued investigation and observation, we strive to unravel these mysteries, ensuring that our knowledge stays in step with the ever-developing universe. Pluto continues to dazzle researchers and enthusiasts of space with its remote nature, which baffles scientists despite its status as a dwarf planet. Its intriguing orbit and characteristics continue to captivate scientists. Recent developments have once again placed Pluto in the spotlight, with the possibility of a gravitational interaction between Pluto and Neptune becoming the subject of all attention in the space community. With Kaku and Tyson bringing this topic to the forefront, the discussion surrounding a potential Pluto-Neptune impact is sure to spark further interest and research. The investigation into these mysterious celestial bodies holds the promise of uncovering new insights into the mechanics of our planetary system. As we peer deeper into space, the dynamic and unpredictability of our celestial neighborhood only underscores the need for caution and ongoing investigation. While the potential interaction between Pluto and Neptune remains a topic of scientific interest, it is crucial to consider the broader context of space exploration and the methods used to study celestial bodies like Pluto. The discovery of potential risks, such as a possible Pluto-Neptune impact, serves as a stark reminder of the immense complexity and unpredictability inherent in the universe. It highlights the complicated mechanics at play within our local planetary system, where even the most seemingly stable orbits may harbor hidden vulnerabilities. This sophistication is brought to attention by space-based tools and techniques physicists and experts use to comprehend the movement of celestial bodies. An important instrument in these kinds of studies is mathematical simulations, which allow scientists to model and predict the behavior of planets and dwarf planets over extended periods. By inputting known parameters like mass, speed, and distance of celestial objects, these simulations can project potential future movements and examine how stable orbits, like Pluto's, are. Such models often rely on powerful advanced algorithms and computers to handle the vast amounts of data and complex calculations. This method is especially important when studying objects whose orbits are unusual, like Pluto, whose path around the Sun is so distinct from the other planets in the solar system. Additionally, the role of gravitational interactions between celestial bodies cannot be overstated. As mentioned, Neptune crosses Pluto's orbit, and the gravitational pull between these two bodies could hypothetically lead to unusual outcomes over very long time scales. However, due to the resonance between Pluto and Neptune, their orbits maintain a committed, stable relationship. This resonance ensures that even though their orbits cross paths, the gravitational forces between Pluto and Neptune are balanced in such a way that a direct collision remains extremely unlikely. The long-term stability of this relationship is a testament to the intricate balance of forces that govern our solar system, yet it also underscores the need for careful observation and study. Even small variations in the behavior of these celestial bodies could lead to significant changes over millennia, which is why continued monitoring is essential. In conclusion, the ongoing research into the dynamics of Pluto and Neptune not only deepens our understanding of these two distant objects, but also offers broader insights into the fundamental workings of our solar system. The study of their interaction and the potential for future changes highlights the delicate balance that exists between celestial bodies. As we explore space further, the lessons learned from studying these distant objects will likely have profound implications for future space missions and the way we think about the stability of other celestial systems. The unpredictability of space and the vastness of what remains unknown call for a commitment to ongoing scientific inquiry. As technology advances and our ability to observe and model the universe improves, we will continue to uncover new mysteries. The future of space exploration depends on our ability to adapt our understanding as new discoveries emerge, ensuring that we remain prepared for whatever challenges the cosmos may present. The dynamic and evolving nature of our solar system, as exemplified by the interactions between Pluto and Neptune, serves as a reminder that space is both a vast frontier and a place of constant change, where even the smallest shifts can have far-reaching consequences. By studying these enigmatic celestial bodies, we not only advance our understanding of space, but also our ability to navigate the unknown. Whether through improved computational models, better telescopic observations, or more refined simulations, the pursuit of knowledge about Pluto, Neptune, and the broader universe will continue to challenge and inspire future generations of scientists, astronomers, and explorers. This journey of discovery is ongoing, and with each new breakthrough, we come one step closer to unraveling the mysteries of our universe. The exploration of space, as we know it, is far from over, and the story of Pluto and Neptune is just one chapter in a much larger tale. It is through continued curiosity, collaboration, and technological advancement that we will continue to chart new courses through the cosmos and deepen our understanding of the forces that shape the universe.